Welcome to part 2 of this video series, Long Distance Performance Testing. This is a continuation of part 1, so if you have not seen part 1, I suggest you see and set the context. In this part, we are going to run 3 different tests. One is the small packet connection rate, the second one would be high concurrency, lots of users leveraging the network, and then we'll have a quality of experience voice video streaming over this long distance network. Let's get to the first test.
Now that we are over the bandwidth test, we would go to as much relevant and important but often overlooked metrics like connections per second. You see, most modern applications are extremely chatty in nature, meaning they generate a lot of new connections. So there is a connections per second and a lot of small transactions, right? So these tests would try to understand latencies, packets per second, and other possible issues that can happen when there is a lot of chattier applications exchanging data between these two distant locations. The setup still remains exactly the same. The client and server through the WAN. The objective is 1 million connections per second because we are going for small packet high rate. The HTTP page size also needs to be changed. We are not going to do those high page sizes. So my page size is just 1024 bytes, fits in a single packet response. And if I see the statistics now, I would be expecting a much smaller throughput, obviously, because we are doing small pages. So my throughput has dropped to 1.5 Gbps. But what would really increase in this case is my connections per second. So you can see 84,000, 88,000 new TCP connections, new transactions every second has been done. You can also notice a small dip in traffic and a small spike in latencies. These are sometimes quite usual in long distance networks, signifying some level of accumulative latencies issues that can at some point bubble up into a bigger issue. We can also look at the TCP statistics. There would be a large number of SYN sent, and obviously we are seeing some retries, which is not unusual because of the sheer amount of connection rate, packet rate that we are sending through this long distance line. So this was my connections per second test. Hopefully it exposed the amount of small packets that this network can handle, and then we'll move to the next test. We advance our testing into another dimension. This is concurrency or concurrent users. See, if there are two locations sharing a lot of traffic, it's not done by just two entities, right? It's probably with hundreds or thousands of users have their unique IP addresses, unique personas. So let's recreate that and run this traffic through. The test obviously is going to use the same setup, and we are using an objective of 60,000 users. The traffic, we are going to simplify it. We'll have just the 64K page that we used previously apart from the others, and we'll remove the post and just have a get with 64,000 bytes, right? So let's directly jump into the results, and you can see I am getting around close to 5 Gbps of throughput with the 64K page. And you can see how the users ramped up to 60,000 users, and the connection rate and transaction rate are holding steady. You can see some latency spikes, which shows me that at some point of time with this added set of users, the system may come across some stress. In the TCP statistics, we see some packet drops, some failures, but not too much, and the 60,000 connections is holding steady. Up till now, we explored the bandwidth, then the connection rate, packet rate, and max concurrency, 3 very common parameters of performance testing. Although, like I mentioned, the bandwidth is the most popular one. Now we are going to go for even more important and even more ignored parameters like quality of experience metrics over two distributed locations. See, anytime the user notices a degradation is generally with poor voice quality, having problems seeing a video streams and like. That itself creates a most number of frustrated users. So in this next set of test case, we are going to create certain traffic that would try to measure the quality of experience over these long distance locations. By now, we already know the drill. We have that same setup topology. The only thing that would change is our objective, which is 10,000 simulated users, and our application. So we now have this voice call. You can see there is an audio stream, video stream, and some sleep to continue that stream. And we also introduce some noise, some UDP noise along with it. So when you go to the statistics, we focus on the audio video statistics, and we can see a steady degradation of users' quality of experience indicated by the mean opinion score. We can see all these packet losses, consecutive packet losses, and the same loss of experience is also seen on videos. 4 is great, anything under 3 is bad quality. So over this long distance network, the user is having really problems in doing voice video traffic, especially when there is a lot of noise, background noise, which is relevant in real life network going on. And that is signified by the low score, mean opinion score of voice and video that you see here in the statistics screen.
That concludes our video 2. In the next video, we are going to send some real application traffic over this network. We'll do some resiliency and failover testing where we'll introduce some delays, impairments, and we are going to do some long duration testing to see how consistent this network is when we send traffic over a longer duration. We'll additionally explore some of the other possible test cases that can come across in this kind of networks. And as always, feel free to see the description to look at the test methodologies and the entire list of test case that has been published in GitHub. Thanks a lot for listening.